Welcome to today's class. Today we shall be discussing how to derive the equations of linear motion. And under this topic, we'll be talking about definition of some terms. We'll be deriving the equations, of course, and we'll be talking about motion under gravity. Now, we'll say linear motion. What do we mean? We mean motion in a straight line or motion on a straight line. For instance, if a car is moving on a straight road, on a main road, a man is walking on the road. You understand? So that is motion in a straight line, which is what we call linear motion. We shall also be discussing vertical motion, which is motion under gravity. For instance, if a ball falls from the top of a building down to the ground, if a mango drops from the mango tree to the ground, or if one throws the ball up the tree, can you see, vertically? So we call it motion under gravity. Alright, so the first thing we'll be defining, or the first term we'll be defining, is displacement. In our last video classes, we defined displacement as the what? Distance in a precise direction, or in a definite direction. When we define distance in terms of direction, we're talking about displacement. I believe you understand. Okay, so displacement has direction, of course. It's called a vector quantity, unlike distance, which does not have direction. They have the same unit, which is the meters. I believe you understand that before. Alright, so what do we call velocity and what do we call speed? Speed is the rate of distance traveled with time. That is, when you say distance over time, what you're doing is you are calculating for speed. The ratio of distance to time is speed, and the unit is what? Meter per second, because it's distance in meter over time in second. Now, but velocity is speed in a defined direction. So we say it is the ratio of displacement to time, or the rate at which the rate of change of displacement with time. Can you see that? That is what we call velocity. Velocity is the rate of change of distance of displacement with time, and not distance. While speed is what? The rate of change of distance with time. Now you can measure your speed in meter per second or kilometer per hour, but the SI unit is meter per second and not this. So whenever you are giving km per hour, you have to convert to what? Meter per second, depending on the question. Okay, now I said this, note this part. When you are asked to define constant speed or constant velocity, sometimes we call it uniform velocity. So we want to know that when a body moves with equal displacement in equal interval of time, no matter how small the time intervals may be, the velocity is said to be uniform or constant. So when you have a body moving with what? Moving at small intervals, can you see, of time, can you see that with equal interval of what? Displacement, that body is said to be moving at what? Uniform speed. Good. So let's move to acceleration. Now when we say acceleration, since since velocity is the ratio of displacement to time, then acceleration is what? The rate of change of displacement of velocity with time. That is, velocity over time gives acceleration. So the rate of change of velocity with time is called acceleration. Do you understand? Now, of course, because of this definition, we can define the SI unit of acceleration as meter per second square. And of course, we know that in our basic classes. Okay, we can also have negative acceleration. If the body is not changing in speed positively, then it must be changing in speed negatively. So negative acceleration is called retardation or deceleration. For instance, when the car is moving at a particular speed and you apply the brake, can you see that the speed reduces? Can you see? So that change in speed over the time it took is called retardation. Can you see that? So let's talk about this evaluation. Sketch the velocity time graph for a body that starts from rest and accelerates uniformly to a certain speed or velocity if it maintains this for a given period of time before it eventually decelerates. So indicate the following: uniform acceleration, uniform retardation, and of course total distance traveled. Alright, I know you must have seen this kind of question before, so just try to lay your hand on it. You can also read more on that. Your answer I will show you before the end of the class. Today we shall also be talking about how to derive the equations of linear motion. We have four basic equations of linear motion. The first is v equals u plus at. The second, and it is a fundamental. The second is s equals to u plus v over 2 into t. The third is v square equals to u square plus 2as. And the fourth is s equals to ut plus half at square. But how did we derive this? How did we arrive at these four equations? Now, in these four equations, some letters, or let me say, the letters, or what to call terms, we appear like VUAT. What do I mean by this? V means final velocity or final speed. U means initial velocity or initial speed. While A means acceleration. T time. S distance. So now we say S, we mean distance. Okay. Likewise, your V, I said this is what? Final speed or velocity. Now, from our basic knowledge, primary school education or secondary school, early secondary school education, we understand that what? That average speed is distance over time. Alright? Okay, now before that, we know that what? V equals u plus at is a fundamental equation. V equals to u plus at. Do you understand? So you must know this one, that this is a fundamental equation. Also, we know that average speed is what? Total distance over what? Total time traveled. Total distance over time. That's average speed. Now, when you say average speed, distance over time, is s is distance, t is time. So distance over time, s over t. But when we say average speed, it means we're going to add the two speeds that we know, which is the initial speed and the final speed. Initial speed is v, is u. Final speed is v. So we're going to add the two of them together and divide it by 2 to get the average. When you say average, you will add and divide by 2. So if these two show average speed, then of course, but we know that what? From equation 1 that v equals to what? U plus at. So, but we have u plus v here. So instead of writing v, slot v equals to what? U plus at. So anywhere you see v, put u plus at. Can you see that? That means we're having s over t equals to u. This u is the same u. Now your v is now what? U plus at. So drop it here. Very simple. Then you have over 2. Okay, now that gives us u plus u, that gives 2u, then your at remains 80 over 2, nothing has changed. Okay, now look at this. If I divide this by 2 and this by 2, if I have 4 plus 8, everything over 2, that can be given as what? 8 over 2 plus 4 over 2. So if I divide evenly by 2, I will have 2 into u, that gives me u. Then 80 over 2 gives me half of 80, which is 80 over 2. And I still have my t here. Now to remove my t, what will I do? I'll multiply each term by t, multiply this by t, multiply u by t, and multiply half 80 by t. If I multiply s by t cancels t, I will have s alone. If I multiply u by t, I will have ut. If I multiply half 80 by t, I will have half 80 times t, making half 80 squared. That gives me the second equation. Bravo! So if you're asked to state the second equation, it is what? S equals to ut plus half 80 squared. That's the derivation of the second equation. Alright, so let's quickly move to the third. Now we know that what? V equals to u plus at from the fundamental equation. Every of the equation is what? Derived from the fundamental. V equals u plus at. Now, having that at our mind, we can square both sides. If you square v, you have v square. If you square u plus at, you have u plus at all squared. So doing that, what do we have? V square equals u plus at square, and that means u plus 80 times u plus 80. So if you expand this bracket, you have u times u square, u times 80 u80, 80 times u80. So I have 2u80. Now 80 times 80 will give me a squared t squared, meaning 80 all squared. So there will be a statistical mass operation here. So we have u squared. Now if I factorize 2a from this and this, if I bring out 2a, what will I have? 2a. In this I'll be left with what? 80. Now don't forget that there is no 2 here. If I bring out 2 as if 2 is there, it means I'm multiplying this by 2. So if I multiply this by 2, I'll have to what? Also divide it by 2, so that to annul the first multiplication, to cancel it out. So I'll be having half 80 squared. Now bravo, but I know that what? That ut plus half 80 squared was derived here. What is my ut plus half 80 squared? It means my s. So just come and put s, replace the ut plus rbt square with s. So I'll have v square equals to u square plus 2as. Hence the third formula, u square equals v square equals u square plus 2as. Alright, good. Now the fourth formula was derived from average speed. From here, look at this. I have s over t, which is average speed, equals to u plus v everything over 2. If I multiply both sides by t, can you see? Multiply this by t and this by t. If I multiply this by t, I will have s remaining because t cancels t. And multiply this by t, I will have u plus v over 2 into t. That gives me my fourth formula. Very simple. Okay, now you can quote the whole formula. So let's now use them to solve problems because that is the main target here. Alright, look at this. Again, the formulas are what? V equals to u plus at, s equals to ut plus rbt square, v square equals u square plus 2as, and s equals to u plus v over 2 all into what? T. Okay, now which one of them do we use to solve? The question itself will tell us what to do. We cannot be, sometimes we combine two out of the four to solve sometimes only one is enough. Now the question will tell us what to do, which formula to use amongst the four. Example 1 says a car moves from rest. When you hear in any question or when you read that something moves from rest or falls from rest, u initial speed is 0. It means the body was not actually moving, so u is 0. But the body, because it has moved, to have a final speed v. So a car moves from rest, write u equals to 0 with an acceleration of 0.2 ms minus 2. That's, sorry, this 2 is square, meter per second square. So you write a equals to 0.2 meter per second square. Find its velocity when it has covered a distance of 15 meters. So write s. S is what? 15 meters. Very simple. Now we have UAS. So what formula do we use? We have to find what? V. Can you see? That's what? V square equals to u square plus 2as. We cannot use v equals to u plus at because we don't have time. Also, we cannot use we are looking for v, so you can't use s equals to ut plus rbt square. You can't use that because that does not even have v. It only has u. So the one that has v is what we're going to use, and the one that has these items u, a, and s. Okay, so we have v square equals, don't forget that u is 0, so 0 square, this 2 is actually square, sorry, 0 square gives 0. 2as, 2a, a is what? 0.2, s is 50. Multiply that together, you get 20. Can you see that? So v is now what? Square root of 20, because I'm finding v, not v square. That will give us 2 root 5, or we say 20 is 4 times 5. So square root of 4 is 2 root 5, or you can leave it as root 20 if you like, and you can also leave it in decimal using your calculator. You can leave it in decimal. Please, your unit is very important, meter per second. Now, number 2 example says a car travels with a uniform velocity of 108 km per hour. How far does it travel in half minutes? Of course, I told you that when you're working, you work in SI unit. SI unit. We can't work with this, and we can work with this. We work with meter per second. Now, so you have to convert 108 km per hour to meter per second, because when you say k per hour, it means what? Velocity. And when you say minutes, it means what? Time. So we have speed and time. What are we looking for? You can't travel with a uniform speed of this. How far? How far? Find distance. So what formula combines distance, speed, and time? That's what? S equals to what? ut plus rbt square. You can also use that, or you use your normal average speed formula. Do you understand that? Okay, but before you do that, you have to do what? You have to do what? Convert the km per hour to meter per second. So if you do that, what we have? V is what? 108 kilometer. Kilometer, for kilometer, 1000 meter make 1 kilometer. So you multiply 108 by 1000 and over. Don't forget this kilometer per. This per means over. Then time, 1 hour. 1 hour is 60 minutes, and 60 minutes is 60 seconds. So you say 1 times 60 times 60. That will give us 3600 seconds. Then you have v as this, t as this. If you do this division, you have your 30. You have this as 30 ms minus 1. T is half minute. That's half times 60 seconds. That gives you 30 seconds. So just do speed equals distance over time. Therefore, distance is what? Speed times time. That's what? 30 times 30. Because we have 30 and 30. That gives us 900 meters. I believe that is clear. Alright, so you have this activity to do. 1, 2, 3. You also have, okay, just take the 3 of them. Now let me give you a hint. One says a train slopes from 108 km per hour with a uniform acceleration of this, how long will it take to reach this? Fine. And what is the distance covered? Okay, we are given the what? The speed, and we are given that's the initial speed and final speed, and we're also given what? The negative acceleration.